We're back again. I actually received a problem from one of you requesting if requesting a YouTube video on how to solve a 3x3 matrices. As you can see, show me how to do 3x3 matrices eigenvalues. So the goal is to get the eigenvalues on the YouTube channel. So from the previous videos, I have shown you how to solve the 2x2 matrices. It's actually the same concept. And if you look at this problem, it looks like it's a weapon formed against your degree. But in reality, this is just a walk in the park. You will see when we actually solve. Without wasting time, let's try to dive into the thing. So what is the goal? The goal is to determine your eigenvalues. The goal is to determine your eigenvalues. So we are required to determine the eigenvalues, and we know from our knowledge of maths 1 and our knowledge of a 2x2 matrix, which I have solved in the previous videos, we know that to determine our eigenvalues are governed by this equation, which is A minus lambda I, which is equals to 0. This is the equation which is governing the eigenvalues, right? So from this point, what are we going to do? What does this formula implies? When we say A minus lambda I, what exactly does this formula implies? This formula implies that you must subtract lambda from your diagonals. What exactly is diagonals? Let's say we have a 2x2 matrix A, which is 2, 1, 3, 4. What exactly is your diagonals? Your diagonals is the element 2 and 4. So if we have the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. What exactly is our diagonals if we're having a 3x3 matrices? Our diagonals is our 1, 5, 9. These are your diagonals. So this formula implies that we must subtract lambda from our diagonals. So let's try to apply this principle in the question that we actually given. So from this point, you can actually subtract lambda from your diagonals, and we know that our diagonals is what? Is 1 minus lambda 0, 0, 0, 2 minus lambda 0, 0, 0, 3 minus lambda, and then equate it to 0. From this point, you're going to apply your knowledge of determinant of a 3x3 determinant, meaning you'll be left with 1 minus lambda into what? Into 2 minus lambda multiplied by 3 minus lambda, which is actually equals to 0. Well, I know some people would have just said 1 minus lambda, 2 minus lambda, 0, 0, 3 minus lambda, which is equals to 0. You're still right, and then you cross multiply. You're still right. So from this point, I don't see any reason why it should be expanding, because already you have your factors. So from this point, you can actually just write the value of lambda 1 as 1, lambda 2 as 2, and lambda 3 as 3. And what can you say about the nature of your roots? You have real distinct eigenvalues. Well, just a recap. You are given the matrix 1, 2, 3, 1, 0, 0, 0, 2, 0, 0, 0, 3, and the goal is to get the eigenvalues. To get the eigenvalues, we use this formula, which is A minus lambda I, which is equals to 0. This implies that what? You need to subtract lambda from my diagonals, and I have shown you that if you're having a 2x2 matrix, your diagonals is 2 and 4, and then 3x3 is 1, 5, and 9. So in our case, we have the matrix A. It means our diagonals are going to be what? 1, 2, and 3. So we're going to apply the principle for this formula, meaning that we're going to subtract lambda from our diagonals. That's why here we have 1 minus lambda, 2 minus lambda, 3 minus lambda. And then after, we're going to apply our knowledge of solving determinant of a 3x3 matrices. So we're going to end up with what? We're going to end up with 1 into 1 minus lambda, and then the determinant and then equate it to 0. From this point, you cross multiply here, you're going to be left with lambda 1 is 1, lambda 2 is 2, and lambda 3 is 3. Therefore, you can conclude that we have real distinct eigenvalues. So this is how you actually get your eigenvalues. Thank you.